Okay, now we do a kind of hands-on session, yeah? And we come to this GIS program. GIS stands for Geographic Information System, and a lot of the things you can also do with statistical programs like Stata and R, but I would argue that command of a GIS program is quite handy for social scientists. With a GIS program, you firstly organize your geodata. You can create spatial units, and that's something you can't do with Stata and R. So you can like create your own neighborhoods, like from scratch, or you just manipulate existing neighborhoods. You can do geocoding. Geocoding is like refer postal addresses to latitude and longitude. That means like location in the real world. You can relate spatial units to each other, so you can calculate distances and you can analyze what's the surroundings, so kind of individual neighborhood aggregates. You can analyze what lies within the specific radius around our units of observation. Within the GIS, you can also do some cartography, so you can draw some maps and export them, or print them, or whatever you like, and you have more degrees of freedom than you have in Stata or in R, so you can do a lot of things. You can also do some spatial statistics, but usually it's a good practice to work with your data and maybe do the illustrations in a geographic information system program, and then export the data set and do the spatial statistics in Stata or in R, so to do these two steps. Because these programs, these geographic information systems, system programs are not, like they can do a lot of things, because I mean they are used by geographers and by cartographers and by a lot of different subjects, and in social sciences we need only a very specific subset of this of the things a geographic information system program can do, but spatial statistics is not something they can do best. So resources, when you look on the internet, there are a lot of resources, and I would advise you that when you have a question, I also sometimes don't know exactly where to click, but when you use Google, then you find it really easily. And there's also this website QGIS tutorials, and they show you with example data exactly how you do some operations. And when you have like more in-depth questions relating to programming and more statistical questions, then you can go to Stack Exchange, and they have also like a section on GIS, and I think that helps you a lot. All right, so we start the QGIS. I will tell you now what we do, and then I do it, and then you do it, and I can put this slide up again. So we start the program, then I will briefly tell you what the different windows in this program mean and can do. Then we install some extensions. So this QGIS is kind of the this open source program has a lot of extensions that are programmed by different people who use some parts of the program more than others, and I hope this works. When it doesn't work, it's not so. It's no catastrophe. Then we find the data for the exercises. We add it as a favorite, and then we import the data and add a base map. And then we have a nice map in our computer. All right, I will show you this. Okay, now you can't see it, right? Because I have to. Yeah. All right. So I open the program really easily. Maybe you have a different version of QGIS, but that doesn't matter at all. Yesterday I installed the latest version because this is in English and not in German anymore, so that we can communicate more easily. All right. So as in a lot of programs, you have different menus on the top. Like project, edit, view, layer, and so on. We will see this later on. Not everything, but some of these menus we will touch on. And then you have three, and here you have a quick access to some of the functions of the program. So if you hover over it with your mouse, then it will show you what it means. Sometimes the icons are not really telling. So. There are three windows. Window 1 is the so-called browser panel, and in this panel you access the file structure of your computer, and you access the different shape files. A shape file is a file where your spatial data is stored. And this is also important because maybe you had a look already at the folder that I gave you, data folder. There are a lot of different files in it. Yeah. But 5 files are always one shape file. So, and when you access it with your Windows, then it gets really complicated. And when you access it by this, then it will recognize what files belong together. So, then in the layers panel, there you have always an overview about the different shape files that you have, like in your map, in the memory of your computer. And here, in this window, it will show the map. So far.
Before it should be QGIS browser, or what kind of program? Because we have a lot of.
No, it's not browser. No, it's not browser.
Well, I launched browser and
It's.
Oh, I have found it. But what?
I think it's desktop. Can it be desktop?
Just a second. It should be. Because it's a lot of QGIS components.
Look for this icon.
desktop.
Yeah. That looks. I don't know. That looks good. It should look like this in the end.
Desktop without grass, maybe. Or with grass.
I don't think you need grass. Did it work?
It very looks like yours.
I have a different version.
Yeah.
Okay, but when it looks roughly like this, then it's okay. All right. I will show you first. Like the first thing is we have to localize the data that we have. Like, and it's shape files, so the file ending is SHP, and there's this kind of icon. And to import the data, for example, on neighborhoods, we simply drag and drop it in the layers panel. And when we do this, we'll see it already on the map. So,
but I think we have not exactly this data. Maybe.
that should be like what I gave you on the USB stick.
So we should copy only one folder, only data folder.
Yeah, the other folders I don't know.
Okay.
Was on the USB stick before.
Давай,
And you can download also the slides from today or from
In the same folder or?
where you store your files. I don't know. I don't care.
No, I mean, is it on the in the same folder on the
Дата, на флешке,
I
которая...
don't know.
Okay.
Ну, вот это, типа, то, что есть на флешке, там есть папка с датой.
No, it's not in the same folder.
It's here. It works. Very good.
Так в кого ще немає?
У Полины нет. Флешки нет. Какой диск?
Ну ви через Facebook можете
Я
один
просто
другому
не
Скачала
перекинути?
папку даты. С флешки. Нет.
Your presentation was in PDF, yes?
Yeah.
Только так сначала скинуть.
All right. So most of you already managed to draw kind of a map, right? And these are neighborhoods, but you can also use the individual data that we have. This is the other shape file, and when I click it here, when I drag and drop it and drop it on the layers panel, then I see the two different shape files. And what this includes is like data on neighborhoods. Yeah, this is constants. Yeah? And it includes individual data of people we interviewed a few years ago. And in the layers panel now we have individuals as first layer, and then we have neighborhoods as second layer, and that also corresponds to how they are displayed. So when I put the neighborhoods as first layer, I can just drag and drop it. Then you see we have on top the neighborhoods and on bottom the individuals. That's probably not very illustrative, so we turn it back. Yeah? And then, like later, I will show you how we can do a nice map from this. That was just to show you like how the different elements work together. So on the left hand we have the browser panel, on the layers panel, and then we have the map, and we can zoom in and out, and I'm sure you will manage how to zoom in and out and everything. What you should do or could do is in the browser panel you have access to the folder of the hard drive C or different other hard drives. But you can also set some favorites, and this is probably a good way to do it. You find the folder data, and with right click you set it as a favorite, and then you can access it more easily. So I already did it. You can try it your own. So what's this data now? Now two things you can do. You can right click, for example, on neighborhoods, and two things are important here. One is the so-called attribute table. The attribute table shows you all the characteristics of the different neighborhoods or of the different individuals. It's just a data table, so what you would find in data, for example. So I can show you. We open the attribute table and a new window pops up, and this is how you would expect it from a statistical program. We have different variables in different columns, and each case in this case it's neighborhoods has a different row. So neighborhood number, I don't know, neighborhood number 44 has 1,440 inhabitants, from this 1,440 inhabitants, there are 1,293 Germans and 147 foreigners. So this is just all the data we have so far on these neighborhoods. And the same you could do for the individual data. I'm sorry, I have not translated the individual data yet, the variables, because we don't use it today, but for tomorrow I will have a better example. Okay, so this is the first thing, and the second thing is you can, the second important, the second important item here in this list is properties. And with the properties window, you can adjust a lot of things relating to this shapefile. And the easiest thing is to adjust the color. That's something we can do very easily. We can, maybe I don't like the green, so I turn it into red, and then I have all the red neighborhoods. That's probably not so nice as well, but it's probably more interesting to have different colors for different shares of migrants or different different density of inhabitants, also on and so forth. But that's something we do later on. For now, for me it was important to just show you how everything relates to each other and to give you a first look at the program. One thing we should probably, now I will show you now, because when everyone does it at the same time, probably the internet is not strong enough. So one thing that's quite important is when you see on web, it can be that it's not already installed with your versions. But in the web menu, you see plug-in, it's called Open Layers, and here you can choose from different internet providers. So, as you already might have guessed, I'm a fan of OpenStreetMap, so I choose OpenStreetMap, and then I add a base map. Base map is like just the background that is loaded from the internet, and that gives me kind of a that takes some time.
I got it.
You got it. Okay, so you're
No,
first.
because I have cable.
All right. So that gives you kind of the background, and the background is how the maps are with OpenStreetMap or Google Maps or so on. And this is a good way when you do your own mapping, or when you have your own items or spatial units that you want to draw, that you want to create, to use a base map and then just look for the place where the spatial unit is that you want to create, and then to draw it yourself. We will do it together, but yeah, you see, nothing happens. That's unfortunate. Maybe Google. Maybe we can all have a look at your computer. Yeah, so you have the individual data, and then you have as a base map, you have, I guess, OpenStreetMap.
Yes.
And you don't have the neighborhoods, or?
Should I put them on? Okay.
Okay, so the neighborhoods are below the base map, probably.
А який ти плагін придумав? Open Map?
Is this extension installed in your versions of QGIS? So you all find the Open Layer plugin? No?
Open Layer should be, yeah. Oh, I have Open Layer, but Open Map.
No, I mean OpenStreetMap or to see everything, to see neighborhoods and individuals.
Okay. Basically, you have the base map, you have And now you have the neighborhoods above the individuals, and so you have some
Where is it? Where is this plugin should be?
in the web.
Yeah, but I have on the map.
Okay, that's so. Yeah, that's
I think there. I think. Manage and install, but open work.
okay. So now that you don't have this extension,
Because I have only done some on this program, that's why.
yeah. Okay. So we have to install this this extension first. I was a bit misguided because with so and you can manage and install different plugins with this menu. Huh? And when you go here, you can just search for Open Layers plugin. This is this one, and install it. That's probably the reason. Yeah. Okay,
But you could try to use different Wi-Fi connection. If our will not work, I could set
okay, but you install it right now, or? Yeah. All right.
А крестик это выбирать или убрать?
Do you have digital connection? No.
I have.
You have internet connection.
Yeah, I exist. This is a local. Just looking.
Okay. Alright, so it needs some time.
Нет, пропало. Только локальная сеть. Коля, а що це? Тільки локальна мережа. Може включити, виключити. Ну до того у мене була мережа. Зараз начебто сповіщає, що є. Значить, є ще одна відкрита мережа. Wi-Fi. Як називається? Wi-Fi.
Точно не запарол?
Да.
What Wi-Fi?
Wi-Fi. Sometimes it works. Ні, ну лучше нашу.
Не, ну, по идее, він ж старий. Ну, ось там, не знаю. Ні. Там десь є такі розсіяні фотофлешки. Показує, що є інтернет. No internet.
No internet?
No.
Yeah, I mean, we can probably, like, now this was the first overview of the program. So now the next step would be that I tell you again something about presentation of spatial data. And during this time, you could try to replicate what we now did. Because so far it was not so complicated, was it? So it should be okay. But the ones of you who have an internet connection and everything work, did you try out with the table, the attribute table and the properties and so on? So you had a look. You tried? All right. So this is all I wanted from you up to this point.
Це потім. Це зараз ми просто дивимося приклад, як працює саме програма, а потім вже будемо розбиратися, як робити стіни доходи.
In order to explain to you what we did now, I think now it's good to have an overview about what spatial data, like what kind of data formats do we have and how do we do all these things. And I would recommend that I go on with the slides and you try to kind of replicate what we did already. Okay? All right. Okay, the agenda for the next, I guess, 45 minutes would be that I tell you something about different types of spatial data, a bit about the terminology, data formats, and then kind of data sources. Where do we get this data from? And I guess that this data sources is something that we come to again when we think about the research questions and what you have in more detail. Okay, so generally it's pretty easy. So spatial data has a reference to a location in the real world by means of coordinates, and coordinates is usually in latitude and longitude. So that's how people on the sea or ships navigate and whatever. And so we have information about the location, and we have information about the units of observations and of their characteristics. And so this is in German, but this is the American blue bar in Kreuzlingen, and we did a small student research project where we mapped all the bars in Konstanz and Kreuzlingen, and we had to evaluate how clean these bars are and what the cost of a beer is. So in the American blue bar, one beer costs 5 francs 50, which is for Switzerland, which is okay for a beer, but still for Germans it's pretty expensive. So and in a way it's just a relational database. So you have the units, you have the locations of the units, and you have some kind of characteristics of these units. These units can be individual observations, these units can be neighborhoods, and so on and so forth. So and you have basically two types of spatial data. One is raster data, and raster data I will show you soon, and the other is vector data, and vector data is more relevant what we are doing. Raster data is in a way just an image. So for example, so a satellite image, for example. And in a raster data image, the informations are coded in the colors. So here, the blacker or the darker, the higher the elevation is, for example. And one characteristic of raster data is that you have like only the resolution that you have. So when you zoom in, then it gets very pixely, and you don't have more information. This is something we don't work with very often because it's more the domain of geologists and so on. But sometimes we have raster data. For example, we had raster data on street noise, and sometimes you have raster data on pollution because the government agencies working with pollution and so on, the environmental ministry also, they often have models of pollution in a city or in a country. And then you could, like here, is street noise, and the lighter the pixels are, the more street noise is. So you see basically the road network of Kreuzlingen here. And when you zoom in, you see that it gets all pixely. So, and what you can do when you have individuals and you have this kind of raster data, you can look for the value of the pixel where the individual lives, and then you see whether there's more pollution or less pollution. So this is the operation we do with raster data. You extract the values of the pixels for different areas or points. So, okay, this is just an aside because we don't have this data very often. What we have mostly is point features or point data. So this is just data where each observation corresponds to one dot on your map, one clearly specified point, specified by the coordinates that you have. Another point of another vector data is line features, and there you have often a road network. And you can combine it. The green dots are the inhabitants, and the purple lines are the roads in Kreuzlingen. And you can do some analysis with this. Vector data, you can zoom into, like it's clearly defined, so you can zoom in as you like and you still have all the information you need. And the third vector data type is you have polygons. So this is areas. This is, for example, neighborhoods, like in this case, or it's countries or cities or whatever you like. Sometimes it's flats or buildings. And as before, they are clearly defined and they have some characteristics. In this case, I think it's the number of Germans living in Kreuzlingen right across the border, and you see the lighter, it's more to the border and there are more Germans live. I mean, that's more or less logical. This is again like an overview about the three types of vector data. You can look it up in the slides if you want. It's about like the definition how the data is built. Like for one point, it's easy. You have coordinates for one point, latitude and longitude. When you have a line, then this line is defined by different points that are connected to each other. And the polygon, by definition, is a line of points, but the first point and the second point and the last point of this line are the same. So this is kind of closed. Yeah, it's also a mathematical definition, and but this is also how the data is stored and how you can generate these different units. So if you draw your own neighborhoods, you have to draw it by a sum of points, and the last point and the first point is the same. Yeah, and of course, like point data is very easily adaptable to our statistical programs, but as soon as you have lines or polygons, you cannot grasp it with Stata or R. You can a bit, but you cannot manipulate it really good because you can't find the points and manipulate the different points. So this is one side. What kind of units or elements do we have? And the other side is what kind of coordinate system do we have or projection. And I have to keep this short because this is such a big topic, coordinate systems, because there's almost as many coordinate systems as there are geographers. At least that's the impression. There are literally thousands of coordinate systems, and usually they have different histories, and every country has its own history of how they measured all the distances in this country. So usually there's some kind of point zero from which people measured everything in the country, like in Switzerland, I think it's in Bern, so you have the coordinates from Bern, and in Germany I don't think it's in Berlin, it's somewhere else. So there are different coordinate systems, and one challenge is when you have different data sources to kind of find one common coordinate system, because like the geographical information system can adjust it on the fly, but it leads to problems. So it's always good to find one common coordinate system. All the data you get from the internet, like the internet has its own, more or less its own coordinate system. It's a World Geographic System from 1984. This is the data that you download from the internet, so it's probably a good way to use this coordinate system. And for most of our analysis, it doesn't matter so much. So we can use this coordinate system because for our purposes it's not very important that we have imprecision of 10 or 50 centimeters. That doesn't matter. For other applications like GPS or military application, it does matter a lot probably, but for our kind of analysis I don't think it matters so much. The second complication with these coordinate systems is that, as you know, the Earth is a sphere, so we live on a globe, and in order to analyze the data, this sphere has to be projected onto 2 dimensions on a flat surface, and as you might remember from school, that's not possible 100%. So there are different solutions to this, and you can there are a lot of discussions. What's the best projection? So one of the oldest and the most widely used projection is the Mercator projection, and what you get from the internet, from Google and all these map services is a Mercator projection. And there are a lot of people criticizing this because it's Eurocentric, yeah? And secondly, it distorts the areas. So Europe appears to be on this projection not as big as Africa, but say half as big as Africa. But in reality, Africa is much larger. So, so people say that this kind of distorts our view of the world, so it makes Europe more important than it really is. That's probably a very good argument when you think of how maps shape our thinking about the world, but for our analysis it's not so important. So you can read this cartoon if you like. So they say the different projections that you prefer tell us something about your personality. Because like map addicts are really strange people sometimes. Okay, you can read it your own. The Gauss-Peters projection is supposed to be one of the best. Yeah, and here you see the real areas, that Africa is a really huge continent and Europe is really, really small. But the Mercator projections has its upsides as well, because it shows the correct outline of countries. So the outline is not distorted. Here the outline is distorted. So that's why the old, like on the sea, when people navigated their ships around Africa and so on, they had to use the Mercator projection because it showed the right coastline. And they were not so much concerned about the size of the areas. Yeah. You can make of it what you want. It's probably for our analysis still good to use a Mercator projection because it's the most widely used, and you won't run into trouble. But if you really want to go into this, and if you want to present your work with cartographers and geographers, you can probably have a different projections. Okay, some things just to remember. When coordinates are given as latitude and longitude, then you usually have a geographic that is a non-projected coordinate system. So you have, say, 47 degrees or 12 degrees north and 12 degrees west or something. And then for everything works fine in your geographic information system, but when you want to do statistical analysis, you should project it to a different coordinate, to a projected coordinate system. And that's something you usually recognize when the coordinates are given as x and y and are stated in meters or kilometers. Then you have projected coordinate system, and then you can run all your statistical analysis. You should usually transform all the layers or shapefiles to a common projected coordinate system, and then you can do whatever you like. And in order to do this, you need a GIS. There are a lot of things that can go wrong, so it's usually good to use a base map and your shapefiles, and when you have points that you know where they are, then you can see whether these projections and transformations were correct or did not go well. Yeah, the data from the internet is are presented in the Mercator projections, but you usually, when you download the data, you get them in latitude and longitude, which points to a non-projected coordinate system. And then you have to project it again. Two things that you don't need now, but probably when you download this data, then it's probably good to have somewhere to look it up. There's different number schemes, and I don't know what it stands for, EPSG. Number 4326 corresponds to the geographic coordinate system, UGS 1984, and the other is the other. So that's just, and then you can find it in the list. So we come back to it maybe later. When geographers talk about their maps, they have a little bit of different terminology, and when you look it up and you pose questions on the internet, you should be able to read this. So a feature is a unit with geographic reference. This is our units of observations. And this is a feature. A field is a characteristic of this unit, and this is analogous to what in sociology we call variables. And an attribute is then the value of this field. Just that you know what we are talking about. And and what we already know is shapefiles. They contain the geographic data, and layers contain the information about the presentation of the shapefile. So when we import, when we drag these shapefiles into our layers window, then we just point to the data that is stored somewhere on our computer, and when we change, for example, the color or the outline or whatever, then it's not stored in the shapefile, but you have to store it somewhere else. So this is more complicated than it sounds. It's very analogous to what we have, but I thought it's probably good to have it on the slide. So what we have now, we have shapefiles, and shapefiles are proprietary data. So it's no open format, but it's owned by this company Esri, and Esri is like the biggest. They make this ArcGIS program, and ArcGIS is like the industry standard. So in Germany and the US, all the geographers will learn with ArcGIS, and when you all the public institutions have this ArcGIS. But ArcGIS is not open source, and what we need from a GIS program, QGIS can do, and can do even better. So ArcGIS is, I often compare it to SPSS. You might have used SPSS, and SPSS is a very old computer program. So you see that it developed somehow, and that makes it very inconsistent. And so you do very similar analysis, and the output looks totally different, and the input looks totally different, and it makes some problems, like because there are so many modules and so on. And ArcGIS is very similar. It's an old program, and they added all those capabilities. And this open source program that we use, QGIS, is newly programmed, so it's much more consistent and it's much more accessible. And because we don't need more functions than there is already programmed in, we can use the open source program. Alright, and these shapefiles, but these shapefiles, because they are so widely used, we still use them. Even though there are a lot of different data formats for storing spatial data, but I think shapefiles, because you get them everywhere, is a good starting point, and we don't have to think about so many things. The complicated thing about shapefiles is that it comprises of at least 3 files. One is storing the geographical information, one is storing the attributes in DBF, that's DBase format. As of like 3 years ago, Excel, you could manipulate it with Excel, no problem. Now you can't anymore, or you can open it, I think, but you can't easily store it, so you have to use Open Office or something else. So you see that's everything a bit outdated, but yeah, it will keep on because everyone is using it. Huh? And there's an index to combine geographic information and attributes, and often you also have a PRG file that tells the program the projection and the coordinate system of the data. So, and when you access this with your normal browser, you have for one shapefile always like 4 or 5 files, and therefore it's it can get really like very hard to see where are all my shapefiles, and therefore it's best to access the shapefiles or manage the shapefiles with your data browser from your geographical information system. A different data format that is widely used is the CSV files, comma-separated values in a text file. Every program, every text editor can open these kind of files, and you usually use this to transfer data between various computer programs. For example, you export CSV files from GIS and import it in Data or R or something else. And this is just tables, and this is what you only can do is that you have the CSV files, you have XY tables, and you have point data. You have like one unit, and this unit is like located on one specific location. All right. Was this clear so far? All right. When there are questions later on, we can always come back to this, or you have it on your slides or something else. Okay, now we come to data sources, and I already gave a quick overview about data sources in this last lecture. You can download a lot of these shapefiles from about administrative units in Europe, from Eurostat, or you can use data of OpenStreetMap. This is a German website, but you can download OpenStreetMap data for different countries and different regions within this country. So also about Ukraine, and this data is in the format of a shapefile, and you can use it in your geographic information system to process it further. You have to process it further because there is too much data in it, and you're only interested in a subset of it mostly. But this is probably a good go-to when you're looking for Ukrainian data. It's in German, but you will find it says country or something. Then it's about the country, and so it should be easy, but we can have a look together.
Is it possible to use maps from a navigation program, like Navitel, maybe other program, or it needs some conversion?
I could imagine that they protect the data, and it's not so easy. I know it the other way around. There are like workarounds that take OpenStreetMap data and convert it to these Garmin files, because there you usually have to pay for additional maps. So people use this free data for their GPS. But the other way around, I'm not so sure. It's probably possible, but it's not that easy. But yeah, I don't know. A lot of open data is also from the census data, like from the US census.gov, and in Germany census 2011, and maybe other data. And an additional source is probably that you can ask your local administration. So a lot of local administration have local data, and they map new buildings, buildings that are destroyed, and they have usually road network data and so on. And sometimes communities share their data, sometimes they don't. I know that in the European Union there is a directive now that this data should be made public, but that takes a long time, and I can't say anything about the Ukraine. A different commercial data, a different data source is of course commercial data. You can buy data. You can use this GeoFabric website. This is data of OpenStreetMap, but they kind of provide this data for free. But when you have special needs and you want to have kind of special analysis, you can also give them some money, then they deliver to you a shapefile in the form that you need. that's probably possible, and it's probably not very expensive, and before like you pay a geographer to do all the work for you is sometimes a good way. Commercial data is also Google Maps, Bing Maps, which is Google Maps from Microsoft, and then there's there's Nokia here, that's also a map service. And you usually get the data for free because you just can download it from the internet or web scraping or whatever. But it's still commercial data, so you have to, like, it depends a bit what you want to do with the data, and sometimes it does not comply with the terms and conditions and so on. And sometimes they restrict the data access, so you can't really rely on this data, but most often you have to. Huh? And then, of course, like, commercial data is available from market research companies, and at least in Germany, they are often very willing to have cooperations with universities, because then they can tell on their website, oh, we have a cooperation with the university, and then you get data almost for free, because they are also interested in the analysis you do with the data. I don't know how it is here, but in Germany, at first sight, this data is really expensive, but then when you say, oh, we have a research project, and so you get it almost for free. Next data source, and this is probably also one of the most important things, or things that you do, is that you geo-reference an address. So you reference this postal address to, well, as you give them coordinates, and so you can geo-reference postal addresses that is assign latitude and longitude to observational units based on the postal address. And this is done. This can be done by using APIs automatically, like web scraping, but it's also implemented as data in R, and there are a lot of Python scripts out there that can do it for you. The development, because there's mostly commercial data, the development is very dynamic, and the concrete access changes frequently. So when I tell you now how it's working, then it can be that in half a year it's not working anymore. But when you're interested in it, we can go more in detail here. I will just show you how it's done on the next slide, and then as you wish. Here again, there's Google Maps. They say this is very good data quality, but you only have 2,500 queries a day. For most analysis, that's sufficient. So when you have 2,500 addresses a day, then after that you have to change the IP address or the computer, or you have to wait one more day. So we had like 200,000 addresses, and there it was not so easy. When you have only 10,000 addresses, then you can wait 4 days and it's no problem. But after these 2,500 queries, you have to pay for 1,000 addresses, I think 50 cents. So it's not so expensive. This Google Maps data is very flexible. You can do a lot of things, but you have to keep in mind that Google saves the addresses on their own servers. So in case of privacy and data protection, it's maybe not the best way to do it. Sometimes you have to do it, and we do it often, but when you think about it, you should not tell others that you do it probably, because when you have confidential data, and even when you tell them only the postal address, and NSA is watching or whatever. Yeah? And the other thing is that the usage does not comply with the terms and regulations of Google. So this API states that you can use this data only. You can use this data only for showing the address on a map on the internet. So this is something that you should probably keep in mind if you want to publish a paper with this data in an American journal. I know of no cases where Google really was active. I know of one case where Google told a programmer of one of the scripts in Data, I think, to stop the development of the script. But the usage of the data, there was no cases that I know of, but it can well be that when you want to publish an American paper, that journal, they say, okay, you use this spatial data, but you're not allowed to, so we cannot publish it. But I mean, if you want to publish in a German or in a Ukrainian journal, it's probably not so much a problem, I guess. Everything also applies to Microsoft and to Nokia. And Nokia here, they say, is the best data quality. I don't know. And then when you want to do it really correctly, you can use OpenStreetMaps. So in this data scripts, you can use OpenStreetMaps, and there you have free data, but the data quality is not really known. We have some analysis in Germany, and we found that like 75% of all addresses were really the same with Google, with Bing, and with OpenStreetMap, but 25%, which can be a lot, were not really geocodable with OpenStreetMaps. So, but just that you know, and this OpenStreetMaps, there's a really dynamic development, and it can well be that in 2 to 3 years you can do everything with open data. All right, but how can we do this georeferences of addresses easily? And for getting started, there's this website GPS Visualizer, and I can show you. Maybe I have internet. I can show you the address, and you can play with it around on your own. So this is the website, and you usually just have some kind of input here, and I can put in my address in Germany, comma Constance, comma Germany, and I can start geocoding. Okay, and so now you have here on a map shown where I live, somewhere in Constance, yeah? And you see here Google's policies do not allow output in text format. I have somewhere, I have the API keys. If you are interested, we can geocode a few addresses. But generally it works like you apply for an API key with Microsoft or Google, and you have to insert it here in this text field, and you insert some addresses in the box on the top, and you get the same addresses together with geo-coordinates in the lower box. And it's just text file, so you can copy and paste it in a text file, and I will show you how to import it in your GIS program. So yes, maybe I can. I have somewhere I don't have it anymore. Here I have the key, the Bing key. Yes. So, and then I import it here. Then I can start geocoding. And then this is what I was talking about. So you have my address in the top box, and then we get latitude, longitude, and then we get the same, the address that we had. And we also get kind of a measurement of precision, which is quite good. When you have thousands of addresses and they don't know the address, then they sometimes assign the location of the street, but that's sometimes not the best. So here the precision is really the correct address, and there it would say like city, then this is just an arbitrary location in the city. But yeah, you can, when you are interested, you can play around with this. I don't know, maybe maybe you can tell me an address in Kiev and we try.
Bishkova 4D.
Oh, I can't.
HLU.
HLU.
SH.
So G. First G should be.
No.
Grushko.
KOV. A. 4G.
4?
Number 4?
Number 4.
It's
okay.
4D.
Okay, 4 is fine.
Okay, now we try.
But I think should be so G.
Well, they
Bishkova.
And here,
Okay,
and then
Prospect 4.
and we
Ukraine.
want the name. So we can, now we can look for the
Coordinates.
number. I will have a look at Google Maps. Is this the correct address? This is
Yeah, it's physical.
This is where we
It's
are.
another building
Yeah.
because you entered 4,
Yeah.
not 4G.
Okay, but you see, Microsoft finds the correct location, and this can be quite handy too. When you have like a couple of addresses and you want to see where they are, then you just insert it here. And this is of course not like when you have 10,000 addresses, then you should use Python or Stata or R. But when you only have like 100 or even 1,000 addresses, you can easily do it with this.
In one list.
In one list, yeah. You would would have a text file with one address each line,
Sure.
and you would just copy and paste it in the input folder. And they say, okay, sometimes they stop, so you should probably do it in chunks of 200 addresses. But when you have 1,000 addresses, it's easily done. So, and then you can just copy and paste the text file from the box below, and then you have your geocoded host
But
address.
you need this API.
You need the API key. Yeah.
How to obtain it?
You see here, get a key, and then there's like they tell you what you have to do. Go to this website, click on create
Also,
key.
they just require to create an account.
Yeah, probably. So you have to look for, there's Google, there's Bing Maps, and there's MapQuest, which is OpenStreetMap data. So, but when it's really important where this address is, sometimes it's also good to geocode it with two different sources and then to compare the location. Because like when you have only 20 locations, then it's easy, you see it instantly, but sometimes it's, it makes mistakes. Probably when it's not in Kiev, then the probability of mistakes is larger than it is.
But it should be big building, that is why it could be difference in location.
Yeah, I mean that's of course a problem. When you think of this street noise data that we have, and we have only like one point for the residential location. Someone might live on the back side of the building and he has no noise at all. Someone lives to the street, to the street, and so he has a lot of noise. So this is something you have to think of probably more theoretical. There are a lot of questions where one precise point is enough. For example, when you calculate the distances to shopping facilities or schools or something else, or the next city. But for other research questions, it's more important to have it's more important to know where in this building or where's the entrance of the building. And that gets more complicated, and there you have to go really into detail. So, for example, when you have these coordinates from Google will show you the coordinate of the middle of the building. And when you have OpenStreetMap data, OpenStreetMap will show you the coordinate of the middle of the front to the road of the building. And for most research questions, that doesn't matter at all. But for some research questions, it does, and there you have to be really accurate, and you have to really think about what you do. Sometimes it's a good idea to have like this one point where you kind of geocode it, but then include a small neighborhood of this point, like 20 meters in diameter, like a circle of 20 meters or something, and this probably captures more like where people live. A related question, which you also have to think about theoretically, is whether the place of living makes sense. Yeah, for a lot of research questions, it's probably the place of working and not the place of living, because people are only there to sleep and not do anything else in the neighborhood where they live. So there you can think of different addresses that you geocode. So sometimes maybe it's better to try to capture not only the home address but also the address where people live and so on. But then again it gets very complicated and you have to get a lot of data from the person. So as a start, it's probably good to have the place of living. All right. So in German they have like in German as in Ukraine, our alphabets have letters that are not really compatible to what the Americans program. So this is a common source of mistakes. So like when you have your addresses in Cyrillic, I don't know whether it works so fine. Now we have it in Latin alphabet and it works perfect. It can be that it works. It can be that it works in 90% of the cases, and that's the same what we have in German with our letters ä and ö and ü and so on. And so we usually transfer these letters to standard alphabet. We transcribe them and then we geocode them just to avoid any possible mistakes. Usually it works. So usually you can just try it and then you see when some addresses make problems that you have to try a different transliteration or something. Okay, and then you do it like this. You georeference your addresses, then you have the lower box, then you keep the order of the addresses. Then you need to generate some kind of identifier, and with this identifier you try to match this with other characteristics. So, and you can also like generate an identifier and try and hope that Google will not recognize the identifier. So this is the problem. When you georeference your addresses, you can't have additional information because they would think, okay, this is part of the address. And so you have to generate an identifier afterwards. So it's all about the order of these addresses, but this is probably not so complicated. Okay, now I would. Now it's 12, right? And today we have to make some break at some point, right? And it's probably best to make breaks because otherwise you all fall asleep or don't pay attention anymore. So